Alright, so for 1.4, we're going to talk about conditions and loops. And so in this lesson what we're going to talk about is writing programs that carry out different instructions based on one or more logical conditions that are true. We'll write programs that repeat instructions until a specific event occurs. And so the question that we're really answering is, would you like to specify conditions that control how your program runs or whether it runs at all? And so let's look at the following program. This is a simple example of an if-then statement, and the way it works is it says if clock.day equals 1 and clock.day or clock.month equals 1, then text window.writeLine Happy New Year, end if. So what this means is if that statement is true, in other words, the computer will read the clock on your computer, the program will read it, and if it is the first day of January, then it'll print on the screen Happy New Year. If not, then it just kind of stays there. Or in other words, it won't print it. So now same kind of thing, but we're going to give it two options. So in this next program, we have an alternate action to perform if the condition is false. And so what this is saying is if the clock hour is less than 12, then write, did you have breakfast? Now if that's not true, it just goes on to the next line, which is end if. And that kind of closes out this if-then statement, and it just moves on to the next line. And it says if the clock hour is greater than 12, which means it would be after 12 p.m., right, afternoon, then print in your text window, WriteLine, did you have lunch, end if. And so basically when you run this program, if it's early in the morning, it'll say, did you have breakfast? In other words, if the clock on your computer is 11:59 a.m. or earlier, it'll print this statement. If it is 12:01, it'll print this statement, did you have lunch? Now in programming, you could do that same thing in more than one way. As a programmer, you could choose what's best. In this example, you might have noticed that the second condition in the program repeats a lot of information of the first. So if we look at that again, we said if the clock hour is less than 12, then text window, WriteLine, did you have breakfast, end if. Then if the clock hour is greater than 12, then text window.writeLine, did you have lunch? Well, we could reduce that. If the clock hour is less than 12, then you print the following line, did you have breakfast? But if this first statement isn't true, then I could carry out the second statement, right? Because if it's not less than 12, then the opposite of that would be that it's greater than 12. So basically, both of these programs do the exact same thing, but this one is a little less work. And the way it works is if my computer clock program is less than 12, then it'll print this line. If it's not less than 12, then this statement is false, and it just moves on to this else statement, and then it'll print the other one. Both programs give you the same result. You can use fewer if, then, and end if keywords if you use the else keyword. Now here's another variation of that. In this particular program, the first thing it'll do is open up the text window and it'll write out a number to the screen. The cursor will blink and then you can write a number and it will save that number in the variable number. Then it'll take the number and divide it by 2. So this remainder equals math.remainder. This is modular arithmetic, so it'll take whatever number you plug in, divide it by 2, and if the remainder is equal to 0, then we know that it's divisible by 2, and so your computer will print off the line, then the number is even, because any even number is divisible by 2. Here, if it's not divisible by 2, in other words, if it's an odd number, then the remainder will not equal 0. Right? It either equals 0 or it doesn't. So if this is a false statement, it just skips over that line, else text window write the number is odd, end if. Okay? So when you're writing a complex program, you want to check to see whether the user typed an even or odd number. There are practical applications for this, but really truthfully, any conditional statement that could either be true or untrue we can plug in here. We just happen to use this remainder command. So now we could do the else if, which is a kind of a variation of else. And let me explain the logic of how this works. So the first line in the program will say, write the line, what is the current temperature in degrees Celsius? Then by assigning the variable temp, and the value that we plug in for temp will be entered in here, and we can read that. In other words, this is the fancy way of telling the computer to take some input. That input is then stored as temp. We really should have read number, but that's okay. But if it reads the temp and the temp value is less than 5, then it'll print it's a very cold day. Now if that's not true, then it moves on to the next line. If else, if temp is less than or equal to 15, then it'll print it's a cool day. Well, if I entered in 38, this statement's false, this statement's false. If else moves on to the next statement. If the temp is less than or equal to 25, then print it's a warm day. Now if else just is it's a way of saying if the first statement above is not true, then try this. Else if that statement isn't true, else if, and then when we get to the last one we have to use just the word else, because that's the last one. So what are we saying? We're saying that, let's say I plugged in 29 degrees. Well, this would be untrue or false, so I'd move down to this line. Untrue, so that would be false. Else if, move down to this line. Now, if this is false and this is false and this is false, my last statement has to be true. So we would just say else. It's quite a hot day, and if, and that closes out this whole little loop. In this example, each condition contains a unique statement that the computer evaluates. When the computer evaluates the statement as true, the computer performs the operation for the condition that proceeds to the end. Loops in small basic programs. You can use a loop to instruct the computer to run one or more statements more than once. You can use the for loop if you know how many times you want the computer to repeat the instructions. You could use the while loop if you want a program to repeat the instructions until a specific condition is true. Let's explore some loop statements. Now this is nice because when we do for end and for loop, in general you use for and for loop to run a code with a specific number of times to manage the type of loop. You create a variable that tracks how many times the loop is run. So in this one we would say for a equals 1 to 10. Alright? Then we would write in the text window the variable a, and for. So now what that means is it'll print 1, because the first time it comes through it starts at 1, then it prints 1. Then it and 4, well it's not at 10 yet. So it goes right back over and loops back, but now it's no longer 1, it's 2. It's not at the end yet. Loops back around. Now a equals 3, 4, 5, 6. And what it does is it prints 1 through 10. Now I could go in and say text window dot write line 1, text window dot write line 2, text window write line 3, or if I'm going to do some sort of sequence like this, I could just make a for and for loop. In this example, the variable contains a value that increases by 1 every time the loop runs. Now you could use the same concept to print a multiplication table. So I could say text window dot write line multiplication table. Then I could arbitrarily choose a number and let the number equal 5. Then I could say for a equals 1 to 10. When I text window dot write and I say a, which the first time will be 1, plus x, plus the number, which is 5, plus the equal sign. Now this is really the time sign and this is the equal sign. Plus what a times the number is, it'll run through the multiplication. So what it does is it says 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15, and so on and so forth. In the previous example, the value for the counter variable in the for loop increases by 1 every time the loop runs. However, you can increase the value by another number if you want to use step as a keyword. So in this example, if we do the exact same thing, we would say step 2, which means it would count by 2. So the first time it would go through, I would have 1, then I count by 2, the next time I would have 3, 5, 7, 9. And it would skip over those other numbers. For this example, you would increase the value by 2 if you write the following code. If you don't know the loop count before you write the program, you could create a while loop for the for loop. When you create a while loop, you specify the condition that is true when the loop starts, but the computer evaluates the condition every time that the loop repeats. When the condition becomes false, the loop stops. Let's write the following program. If we say that a equals 10, while a is less than or equal to 100, print off a. Then in the next line it'll say a is then going to be equal to a plus 10. And this will crank through and while until our value for a is greater than 100. What it will do is count by tens. So we'll start with 10 because that's the original a value. A is still less than 100, so it'll print a equals 10. Then it'll reassign the value for a as a plus 10, which is 20. So it says end while, so it loops back up here. Now a is 20, which is still less than 100, and it'll go through. Then a becomes 30 because we add 10 to it. 30 is still less than 100. Now a becomes 40. A is 50, 60, 70, 80, and when it gets to a equals 100, it'll print it off. But now, when I come back, a is greater than 100. It will be 110 at some point. Well, then it won't print. So that's why over here we see 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Let's summarize what we've done here. So what we've learned how to do is write programs that evaluate logical conditions and perform operations based on those results. We've learned how to write programs that repeat one or more instructions, either a specific number of times or based on a logical condition. We should know how to create a program to convert one or more students' scores from a percentage to a letter grade. First, ask the user to specify how many grades will be calculated. Then ask the user to specify the range, or the first percentage, and then convert it to the letter grade for the following criteria. Okay, so now this is a little trickier than it looks. Here's the criteria. They want us to say that if it's 75% or more, then we convert it to an A. If the percentage is 75, but 75 but more than or equal to 60, convert it to B. If the percentage is less than 60 or more, between 60 and 35, convert it to a C, and if it's 35 or lower, convert it to a D. I'm going to use an actual grade. So let's close out of this, and let's do that. So the first thing that I want to do is I want to create a text window, and I want to write a line, and in that line what I'd like to do is say how many grades do you need converted? Okay, now I'm going to run this, and what it'll do is it'll just print that. It'll say how many grades do you need converted. Okay, cool. That's all I needed to do. Now in the next line I want to receive some text. So in the next line I'm going to say number of grades. equals, and then we say text window dot read. Now I want them to enter in a number value. Now what that does is it will ask me how many grades I have. Now to double check and make sure that my program is working properly, I'm going to say text window dot write line and say so you want to convert space plus how many grades? The number of grades plus so it's going to say so you want to convert and then insert the number value that I print, and then I'm going to put a question mark and close it. Now to double check, I'm going to hit run, and it says how many grades do you need converted? I'll say 4. So you want to convert 4 blank. Oh, you know what, I should put the word grades in there, right? So I'm going to change this to 4 space grades. Oh, I gotta spell grades. Okay. Now I'm going to enter in a different number. You want to convert 7 grades? Yep. And so now what I need to do is I need to write a program that will end so we got to go back. I want the program to repeat. I want it just to convert it and then come back and then convert it and come back and convert it and come back. Well, how many times do I need to run this conversion program? Well, it depends on how many grades I have. So I'm going to say, let me think about this. Let's do a for loop. So if I say for A equals 1, 2, now I'm going to type in number of grades. Now what that does is that'll run through the program so many times. It'll run through it one time, then a second time, then another time, and that's it. And then way down here at the end, I'm going to say end 4. And then I'm going to type some stuff in here. So now inside here, what I need is the if-else statement. I'm going to change it to an actual letter grade like we do here. I'm just going to say 90, 80, 70, and so on and so forth. So what I'm going to do is I'm going to say if-else and then have a series of else-if statements, and then that'll crank through and do my calculations for me, and it's going to run through it so many times. So just looking at my notes here because I wrote this down. Okay, so what I'm going to say is if oh wait, we want to print something off. So the first thing we want to do is we want a text window and I want to write a line and so what I'm going to do is I'm going to say please enter the percentage for grade number. And so for the first grade, I'm just going to put number of grades, right? Because this is, oh wait, actually I'm going to put an A. And then what I'm going to do is I'm going to say numbers only, or number without percent. Later on we'll learn how to change all that and restrict what we're doing. Alright. And then in the next line, we need to read it. So I'll say text window dot read number, and I need to assign that, so we'll say percent equals this. And from there, what I will do is now I need to do the if else. Dang it. I gotta stop recording.